All right, we have our experimental setup right here, as described before. What I want to point out to you right now is we want to actually know what the exact length of the string is. That's going to be constant for this part of the experiment. From this end right here to this end right here, I have it set to exactly 170 centimeters or 1.7 meters, because we're probably going to want to be in meters here. And what we're going to do is we're going to change the frequency in our frequency oscillator. And right now it's set to a small 1.2 hertz, but we're going to dial it up just a little bit until we see a pattern here. Now this is actually going to be the first recognizable pattern here, and we'll talk more about this as we go through the experiment, but right now I have it set to 6.8 hertz. So my string vibrator is oscillating up and down 6.8 times every second, and what you see is we're going to call this one loop. Essentially, it's kind of like a jump rope pattern here. This is called the fundamental frequency, or the first harmonic frequency, and right now it's set to 6.8 hertz. Now in that other column you're asked, what is the wavelength of the wave? The wavelength of the wave is always equal to the length of two loops. We only see one loop in front of us. One loop is 1.7 meters, so two loops would have to be 2 times that, or in this case 3.4 meters. So that's our very first data point. What I'm going to do is actually double the frequency to 13.6. If I double it to 13.6, if you take a look at that pattern, and I actually want you to take a look at the pattern really closely, because when we get up to the higher frequencies, you see something kind of weird, and it all has to do with the refresh rate of the camera, not actually what's happening here. Right now, how many loops is this?
2.
2 loops. And what you see is that the length of 2 loops spans the entire length of the string here. So the length of 2 loops here is 1.7 meters. When we go higher, we're going to get a wavelength that's smaller than the length of the string itself. Alright, so let's dial the frequency up to a higher frequency. We're going to go to, you may notice that, you know, in between we don't really get the best patterns here, but when we lock in on specific increments of that original frequency that I did, right now we're at 20.4 hertz. How many loops do we see on that one? How many loops?
3.
3. All right, now this one, it actually is going to be measurable here. We're going to measure the length of the 2 loops here. Measure from this point right here past first loop all the way to the second loop. So I got my meter stick here. So this wavelength of the wave is over 1 meter. Let's bring it all the way over to the second node here, and what I get is about 1.11 meters here, or 1 meter and 11 centimeters. So 1.11 meters is the wavelength of our wave for our third harmonic. Okay, that's great. We're going to dial up the frequency again. Let's go to 27.2. And we really only get these patterns at specific increments of the frequency here. So you see 27.2. What is the number of loops we have?
4.
Fourth harmonic right here. So measuring from here to here, I'm going to estimate it's about 84 centimeters. What the heck was that? Go check for dead victims. What did I say? 84 centimeters? There's our fourth harmonic. 27.2 plus 6.8. Let's go up to 34 hertz now. We're just going to keep going higher and higher and higher. .34 hertz. And this is what I was talking about. If you're looking at this, it kind of looks like it's a lot slower than the other ones. You may be able to pick up on the blurriness. Basically, the cycle rate of our string is something in tune with the refresh rate of our camera, so you see kind of weird things. This happens like when you look at a wheel, and sometimes it looks like it's spinning backwards here. But how many loops do we see?
5.
5 loops. So we're going to measure from here. First node's right there. Second node's right here. Looks to me 66 centimeters or 0.66 meters for our 5th harmonic. What we'll do is we'll go up another 6.8. We'll go to 40.8. Now our string vibrator's up, oscillating up and down 40.8 times per second. And so if we look at the number of loops here, looks to me like there's 6 loops. So we have 6th harmonic here. And we want to measure from here to here, which looks at about 54 centimeters or 0.54 meters. And we'll keep going. Up another 6.8 to 47.6. How many loops do we see?
7.
7. And we got rid of that god awful sound too. Going from first node, or the first loop to the second loop, we're at about 48 centimeters or 0.48 meters. We'll go up again, another 6.8, 54.4 hertz. So there we are, 54.4 hertz. How many loops we got? 8 loops. And if we measure from here to here, looks like 42 centimeters or 0.42. And we'll do this again, up another 6.8. So we're going to go to 61.2 on the sine wave generator. How many loops we got?
9.
9 loops. And whoa, this looks really crazy on the camera right now. It'll be interesting to see if it comes out like that in the video that I end up posting. So it actually looks like it's moving in slow motion. Again, that's really not what's happening here, but it just happens to be that's what the camera's picking up with its refresh rate here. So we got 1 loop right here. You may be able to see that that point shouldn't be moving. And we got 2 loops right here. To me, looks at about 38 centimeters or 0.38 meters. Now we can keep going higher and higher with this, but I think you're only required to go to the 9th harmonic. But if you just look, just for fun, let's put it up to 68, and you should see that we're going to get 1 higher harmonic here. And you may notice that this really isn't in tune with the refresh rate of the camera, so you end up starting to see those loops again, but you can see the nodes pretty clearly, and this will keep happening. There's actually no limit to how high we can go with our harmonics, but it does become harder and harder to see with your eyes as you go higher up in frequency. So this should be all our data for part 1. Hopefully I didn't screw anything up. I'll end up going through the video, see if we did or not.